In this video, we have a diode hooked up forward biased, and we have a bulb in the circuit. I have my circuit breaker to protect the circuit, and I have a ground path back to the battery. And currently the meter is connected across the battery so we can see the voltage that the battery is supplying to the circuit. And right now it says about 12.25. And what I'm going to do is I'm going to move the meter leads over to the diode to see how much voltage the diode is using up. And I'm also going to move the meter leads over to the bulb to see how much the bulb is getting. And just keep in mind that it's 12.25 the battery voltage, and we would expect the diode to use up some of the voltage, but not too much, and we would expect the bulb to get whatever is left. So let's make a measurement across the diode. So right now I have my meter leads across the diode, and I have the positive lead to the anode side and the negative lead to the cathode side, which has the stripe on it. And notice I'm reading 0.75 volts. So if that's the case, I would expect that the bulb is getting perhaps 11.5 or somewhere around there, because we would have to subtract the 0.75 from the battery voltage. So let's move the leads over to the bulb and we'll see what we have. All right, and as you can see, the bulb is getting 11.41. And the reason it's not getting 11.5 is because each of the conductors, or the jumper leads that I have and the path going back to the battery, they all have some resistance, so they will use up tiny, tiny amounts of the voltage, but just not as much as the diode. So that's why the bulb's only getting 11.4, so perhaps 0.1 volt is being used up by all of the rest of the wiring and connectors in the circuit.